So we're going to learn how to train your neural network. And we're going to start over here. First we need a sentence. So this sentence is, instead of turning left, she turned. And we know what the correct answer here. The correct answer is the word right. So that right, we put up in this area here, we call it the target. And we know what the target is. The target is the word right. And if we've trained our neural network correctly, when we look and go to see what the neural network output comes to be, we hope it's going to be equal to target. So let's start now. So let's start training. So the first thing we have to do is we have to take this sentence, which is text, and we have to transmit it into the network as numbers. That's called embedding. And you create a vector to do that. And so what happens is the process, we'll just say embedding happens, and we're able to create an input layer, down here, an input layer. That is our translation of the ideas that were in text now into numbers. And we start with this set of numbers. And now these things that we have in this input layer are called nodes. Nodes. And so the nodes are connected, and you'll notice that every node is connected to every other node in the next layer. Now this happens all the way through the network, so this connection happens here and here and here, but I'm not drawing it because there's too many lines. Okay, so now these things in here are called weights. And the weights are somewhere between -1 and 1. Okay, and they tell you whether it's a negative weight or if it's a positive influence. If it's 0, it has no influence at all. And so that's how it starts. So now what happens is you start with the input layer, and the combination of these weights lights up some of these lines, like this one here, maybe these ones here, do a couple more here and there, down here. And all of a sudden, this perceptron, kind of like a neuron in a nerve cell, lights up. It says, oh, I'm activated, this one's activated too, maybe this one too. So now these nodes are activated. And now remember, we've got connections all the way inside here. Those get connected to something else. And all of a sudden, you've got 3 of these ones, or maybe 4 of those connected. So now these light up. Each one of these lines represents a weight. So remember, they're all different weights all the way through here. And again, now you got this transmitted to here. So now you want to move this over. It's going to start estimating. This one becomes really important. These ones don't become that important. We got that one again. Maybe this one gets lit up. And then finally, we reach the output layer. And the output layer tells us that these things, let's say this one and this one, are the most important due to the weights all the way through this neural network model. So the output layer says this, and then it translates it back into a word. So now we had the embedding function over here that took words and put them into numbers. Now we're going to take numbers and put them into words. And it comes out with the word, are you ready? Drum roll. Back. Ugh. Back. That's not right. That's wrong. So here's the problem now. Our neural network and all the weights that we've got inside it, we now have to change them. Because by changing and adjusting the weights, we'll get it to so that it comes back with the word right. That's what we're looking for. So we have to go backwards now. We have to now take this model, and I'm going to take it all the way back to the input layer using this sentence. And what am I going to do? I'm going to start changing the weights. Changing the weights so that the probability of the word right coming up higher rather than the word back is what we call, and I'll put it up here, backward propagation. And that is the technique that Geoffrey Hinton came up from the University of Toronto with that has neural networks learn. And so now what you do is through backward propagation, you just keep feeding it the information. You go through and then we've got hundreds of millions of sentences out there to learn from. And we just keep feeding it, and the weights keep adjusting all the way through the model until finally you've got a model that's very stable and is providing language. That is training a neural network.